Neho, and welcome to the last part of our Unit 5 presentation on Advanced Data Modeling for CIS 3107 Database Modeling. We will be covering sections 5.4 in our text. Data modeling and database design require skills that are acquired through experience. In turn, experience is acquired through practice by regular and frequent repetition and applying the concepts learned to specific and different design problems. In this third lecture, we will learn how to use flexible solutions for special data modeling cases through 4 special design cases that highlight the importance of flexible designs, proper identification of primary keys, and placement of foreign keys. Foreign keys work with primary keys to properly implement relationships in the relational model. The basic rule is very simple. Put the primary key of the "one" side, known as the parent entity, and the foreign key on the "many" side for the dependent entity. However, where do you place the foreign key when we are working with a one-to-one relationship? The answers are found here in Table 5.5, which shows the rationale for selecting the foreign key in a one-to-one relationship based on the relational properties in the ERD. In the first case, one side is the mandatory and the other side is optional. The action taken here is to place the PK of the entity on the mandatory side and the entity on the optional side as a FK, and make the FK mandatory. In the second case, if both sides are optional, then select the FK that causes the fewest nulls, or place the FK in the entity in which the relationship role is played. The third case, where both sides are mandatory, requires that we consider revising our model to ensure that the two entities do not belong together in a single entity. The figure 5.7 illustrates the employee manages department relationship. Note that in this case, employee is mandatory to the department. Therefore, EMP_NUM is placed as the foreign key in the department. Alternatively, we might also argue that the manager role is played by the employee in the department. As designers, we must recognize that the one-to-one relationships exist in the real world. Therefore, they should be supported in the data model. In fact, a one-to-one relationship is used to ensure that two entity sets are not placed in the same table. In other words, employee and department are clearly separate and unique entity types that do not belong together in a single entity. Normally, data changes are managed by replacing the existing attribute value with the new value, without regard to the previous value. However, in some cases, the history of values for a given attribute must be preserved. From a data modeling point of view, time-variant data refer to data whose values change over time and for which we must keep a history of the data changes. Some time-variant data is equivalent to having a multiple valued attribute in our entity. To model this type of time-variant data, we must create a new entity in a one-to-many relationship with the original entity. This new entity will contain the new value, the date of the change, and any other attribute that is pertinent to the event being modeled. For example, if we want to track salary histories for each employee, then the EMP_salary attribute becomes multi-valued, as shown in Figure 5.8. In this case, for each employee, there will be one or more records in the salary_hist entity, which stores the salary amount and the data when the new salary goes into effect. Other time-variant data can turn a one-to-many relationship into a many-to-many relationship. For example, if we want to keep track of the history of all department managers as well as the current manager, we can create the model shown in Figure 5.9. Here, the MRG_HIST entity has a one-to-many relationship with employee and a one-to-many relationship with department to reflect the fact that an employee could be the manager of many different departments over time, and a department could have many different employee managers. Because we are recording time-variant data, we must store the date_assign attribute in the MRG_hist entity to provide the date that the employee, EMP_NUM, became the department manager. The primary key of MRG_hist permits the same employee to be the manager of the same department, but on different dates. It is worth emphasizing that the quote manages unquote and quote employs end quote relationship are theoretically optional and redundant in practice. We can always find out where each employee works by looking at the job history and selecting only the most current data row for each employee. However, as we will discover in our future structured query language SQL units, finding where each employee works is not a trivial task. Therefore, the model represented in Figure 5.10 includes the admittedly redundant but unquestionably useful quote manages end quote and quote employs end quote relationship to separate current data from historical data. Creating a data model requires proper identification of the data relationships among entities. However, due to miscommunication or incomplete understanding of the business rules or processes, it is not uncommon to misidentify relationships among entities. Under those circumstances, the ERD may contain a design trap. A design trap occurs when a relationship is improperly or incompletely identified and is therefore represented in a way that is not consistent with the real world. The most common design trap is known as a fan trap. A fan trap occurs when we have one entity in two one-to-many relationships to other entities, thus producing an association among the other entities that is not expressed in the model. For example, assume that the JCB Basketball League has many divisions. Each division has many players, and each division has many teams. Given those, quote, incomplete, end quote, business rules, we might create an ERD like the one here in Figure 5.11. The division is in a one-to-many relationship with team, and in a one-to-many relationship with player. Although that representation is semantically correct, the relationships are not properly identified. For example, there is no way to identify which players belong to which team. Figure 5.11 also shows a sample instance relationship representation for the ERD in the bottom half. Note that the relationship lines for the division instance fan out to the team and player entity instances, thus the quote fan trap end quote label. Figure 5.12 shows the correct ERD after the fan trap has been eliminated. Note that in this case, division is in a one-to-many relationship with team. In turn, team is in a one-to-many relationship with player. This also shows the instance relationship representation after eliminating the fan trap. Note how easy it is to see which players play for which team. However, to find out which players play in which division, you first need to see what teams belong to each division. Then you need to find out which players play on each team. In other words, there is a transitive relationship between division and player via the team entity. Although redundancy is often good to have in computer environments such as multiple backups in multiple places, redundancy is seldom good in a database environment. As we learned in Unit 3, redundancies can cause data anomalies in a database. Redundant relationships occur when there are multiple relationship paths between related entities. The main concern with the redundant relationships is that they remain consistent across the model. However, it is important to note that some designs use redundant relationships as a way to simplify the design. An example of redundant relationships was first introduced in Figure 5.9 during the discussion of maintaining a history of time-variant data. However, the use of the redundant quote manages end quote and quote employs end quote relationships was justified by the fact that such relationships dealt with current data rather than historical data. Another more specific example of a redundant relationship is represented in Figure 5.13. Note the transitive one-to-many relationship between division and player through the team entity set. Therefore, the relationship that connects division and player is redundant for all practical purposes. In that case, the relationship could be safely deleted without losing any information generation capabilities in the model. In summary, in a one-to-one relationship, place the PK of the mandatory entity as a foreign key in the optional entity, as an FK in that entity that causes the fewest nulls, or as an FK where the role is played. Time-variant data refers to data whose values change over time and require that you keep a history of data changes. To maintain the history of time-variant data, you must create an entity that contains the new value, the date of change, and any other time-relevant data. This entity maintains a one-to-many relationship with the entity for which the history is to be maintained. A fan trap occurs when you have one entity in two one-to-many relationships to other entities, and there is an association among the other entities that is not expressed in the model. Redundant relationships occur when there are multiple relationship paths between related entities. The main concern with redundant relationships is that they remain consistent across the model. Thank you for watching our Unit 5 Part 3 presentation. The diagrams and content of this lecture were derived from our textbook. For a more detailed treatment of these concepts, please review pages 182 to 188 in our text.